Hello, Professor and everyone. My name is Thun Phai, and today I'm going to present about the term project for Calculus 2 in semester 2 year 1. My today's topic is indeterminate form and L'Hopital rule. In determinate form and L'Hopital rule will be covered in three parts, which are indeterminate form, infinity over infinity, infinity times 0, infinity minus infinity, and the last part is indeterminate power, 1 to the power of infinity, 0 to the power of 0, and infinity to the power of 0. So let's talk about the first part, which is indeterminate form, 0 over 0. If we want to know how the function of x equal to 1 minus cosine of x over 3x cubed, we have near x equal to 0, we can examine the limit of x as x approach 0. But we cannot apply the quotient rule for limit because the limit of the denominator and numerator are 0 and 0 over 0 is undefined, so we cannot use that rule, but can use L'Hopital rule on the limit, and we will see it later. So if the continuous function of h and g of h are both 0 at h equal a, then the limit of h approach a of f of h over g of h cannot be found by substituting constellation, rearrangement of term, and other algebraic manipulation. And other meaningless expression often occurs such as infinity over infinity, infinity times 0, infinity minus infinity, 0 to the power 0, infinity to the power 0, and 1 to the power of infinity. So let's talk about the theorem 5, which is L'Hopital rule. Suppose that the value of at a equal to g at a equal to 0, that f and g are differentiable on an open interval I that containing a, and that g prime of x different from 0 on I. If x different from a, then the limit as x approach a of f of x over g of x equal to limit of f prime of x over g prime of x as x approach a, and we assume that the limit on the right side of the equation is let's see the example 1. We will add the following limit. A, the limit as h approach minus 2 of x plus 2 over x squared minus 4, which is the 0 over 0 form, that is the indeterminate form. So we apply the L'Hopital rule on this limit, and so we differentiate the numerator and denominator, we got 1 over 2x, and we insert as x equal to minus 2, we got the answer minus 1 over 4. Another example is the limit as x approach 0 of sine of phi x over 2h. So we differentiate numerator and denominator, we got 5 times cosine phi x over 2. So the answer is 5 over 2. Let's talk about the using of L'Hopital rule. To find the limit of h approach a of f of x over g of x by L'Hopital rule, we continue to differentiate f and g so long as we still get the form 0 over 0 at x equal a. But as soon as one or the other of these derivative is different from 0 at x equal a, we stop differentiating. L'Hopital rule does not apply when either the numerator or denominator has a finite non-zero limit. We see the example 2. Be careful to apply L'Hopital rule correctly. For example, the limit as h approaches 0 of 2 times cosine of h minus 1 over h squared plus 7h. We got minus 2 times sine of h over 2 times h plus 7, and we insert h equals 0. We got 0 over 7, so the answer is 0. But if we continue to differentiate in an attempt to apply L'Hopital rule one more, we get the limit as h approaches 0 of minus 2 times cosine of h over 2, and we insert h equals 0, we got the answer is minus 1, which is the wrong answer. Because L'Hopital rule can only be applied to the limit that scale indeterminate form. We see that the denominator is 7, so it is different from 0, so which is not an indeterminate form. This is the example 3. In this example, the one-sided limit are different, and we see the difference between them. So the first one is the limit as h approach 0 on the right hand side of sine of 2h over 3 times h squared, and we differentiate the numerator and the denominator. We got 2 times cosine of 2h over 6 times h, and as h is positive, we got the answer is positive infinity. And for negative h, the answer is different. Just the answer is negative infinity. So this is the difference between one-sided limit. Let's move on to the next part, which is indeterminate form: infinity over infinity, infinity times 0, and infinity minus infinity. Is f of h approach positive or negative infinity, and g of h approach positive or negative infinity of h approach a, then the limit of h approach a of f of h over g of h equal to limit of f prime of h over g prime of h as h equal approach a, provided the limit on the right and on the right side is this. In the notation as h approach a may be either infinite or infinite. Moreover, h approach a may be replied by one-sided limit. So we see the example 4. Find the limit of this infinity over infinity form. Example: the limit h approach as h approach infinity of y times x cubed minus 2 times h over 7 times x cubed plus 3. We differentiate the numerator and denominator again, so we got 15 times x squared over 21 times x squared. So we differentiate again, we got 30 times h over 42 times 8, and we cancel it out, got 30 over 42. So we got 5 over 7, which is the answer. Let's see one more example. Example 5. Find the limit of this infinity times 0 for. This example limit as h approach infinity of h times sine of 1 over h, which is the infinity times 0 form. So we let n equal to 1 over h. We got limit as n equal approach 0 on the right hand side of 1 over n times sine of n. So we got sine of n over n. So the answer we got is 1. So let's see one more example. Example 6. find the limit of this infinity minus infinity form. Example, limit in as h approach 0 of 1 over sine of h minus 1 over h. So we got x minus sine of h over h times sine of h. So we differentiate it, we got 1 minus cosine of h over sine of h plus h times cosine of h, and it's still 0 over 0 form. So we differentiate one more time, we got sine of h over 2 times cosine of h minus h times sine of h, and we insert the h equals 0, we got 0 over 2, which is equal to 0. That is the answer. So let's move to the last part of the presentation, which is indeterminate power 1 to the power of infinity, 0 to the power of 0, and infinity to the power of 0. Is the limit as h approach a, natural logarithm of f of h equal L, then the limit of f of h as h approach a equal to limit of h approach a of e to the power of natural logarithm of f of h equal to e to the power of L, and a here might be finite or infinite. So we see the example 7, find this limit. Example, limit as h approach infinity of h to the power of 1 over h is the infinity to the power of 0 form. So first we let f of h equal to h to the power of 1 over h. So we got the limit as h approach infinity of natural logarithm of f of h equal to the limit as h approach infinity of natural logarithm of h to the power of 1 over h. So we got the limit as h approach infinity of natural logarithm of h over h, which is the infinity over infinity form. So we differentiate the numerator and denominator. We got 1 over h over 1, and so the answer is 0 over 1, which is 0. Therefore, the limit as h approach infinity of h 1 over h equal to the limit as h approach infinity of h equal to the limit h approach infinity of e to the power of natural logarithm of h, and which is equal to the e to the power of 0. And so we got the answer, the final answer is 1. So this is for my presentation. Thank you, sir, and thank you everyone for your attention. So goodbye, have a nice day.